In this video, we'll talk about dialations, and in particular, how to do them involving a coordinate grid. So to kind of just bring up an example to kind of motivate the thinking here, let's say we wanted to dilate a triangle with the vertices of the coordinate 1, 2, 2, 5, and 0, 1 by a factor of 3. And this is kind of interesting because what does all this actually mean? What does it look like? And this is what this video is really going to dive into. So what we have here is a computer-generated image of this triangle that we've talked about. We have our coordinates 0, 1, 1, 2, and 2, 5. And what we're really trying to figure out is what are they talking about? What does it mean to dilate something? And the idea is we're talking about dilating about the origin. And it makes sense, we kind of need a frame of reference if we're talking about dilation. We need a point to dilate about. We are increasing the size of this triangle, and the idea is if we're talking about a scale factor of 2 even. Is that what we're ultimately doing is we are doubling the distance from our origin point, our dilation point. And it turns out it's actually pretty simple and logical to do it from the origin. It gets more complex if we're dilating about a different point, and we'll talk about that later. That'll probably be another video. But for the moment, let's just think about dilating about an origin. So basically what's happening is I am doubling my distance from this point. So if I'm looking at this point here, I need to move it towards twice as far away. And the reason I picked that point is it's very easy to see. But then we look at these points. And what do we do with them? What do we do with A and B? Well, it turns out that we can kind of project a line. And they increase the distance. They double. So the idea really is that A is going to go here, and B is going to go even further. It'll go off the screen just because of the height, but it'll be up at 2 or 4 and then 10. So again, here's a computer-generated image. I used GeoGebra to dilate this for us to kind of show what's happening here, to kind of demonstrate what I was drawing on the previous frame. So the idea is this new point is 0, 2. A moved from 1, 2 to 2, 4. And I think we can kind of pretty clearly see it here. It's the scale factor of 2 in this case, from the red to the blue figure. And we can start to notice the trend is that I'm doubling my coordinates in this case. And we can see the same thing with coordinate B. B moves from 2, 5 to 4, then 10. And again, we see that relationship. Both of the coordinates are again doubled. And that kind of will motivate our thinking for, okay, what happens when it's a scale factor of 3? So back to our original question. What happens if instead of doubling, I am tripling the size? I'm dilating it by a factor of 3 about the origin. And it turns out it's actually pretty simple to find the new vertices. So the idea is I'm going to multiply all of these by 3. So this first point, I believe, which was our A point, will be 3, then 6. Likewise, 2, 5 is going to turn into 6 and 15. And likewise, 0, 1 is going to turn into 0, 3. These would be my new vertices right here. And with that, I could plot my new triangle and do my dilation. That one would be 3 times the size of the original triangle. And the process is pretty simple. The reasoning behind it is a little complex. And I just wanted to kind of show you ultimately what we're looking for when we're trying to solve these kind of problems. We're looking at just this process. Like, okay, scale factor of 3. If I'm going about the origin, I can just triple. If it's a 4, I quadruple. If it's by 10, multiply all of them by 10. And what will the result will be is a triangle that is however many times the size. And this also works if we're reducing something. If we want it to be half the size or a third of the size, we can reduce in terms of dilation as well. But the same process will apply. Whatever the scale factor is, I multiply the coordinates by that factor.